Hello everyone. In this problem on electrostatics from Pathfinder, we are given that there are two particles of mass 100 grams and charge 10 microcoulomb, and they are released on a horizontal plane at a distance 1 meter from each other. So this is the initial situation that I've shown in this diagram, that they are 1 meter apart. I've shown them using blocks, right? Now there is friction on the surface, and because they are charged, due to mutual repulsion, they move apart, and there is also friction, so work is being done against friction as well. So we have to find the maximum speed acquired by the particles after they are released, right? So of course we'll just assume that कोई एक डिस्टेंस x है जिसके बाद स्पीड मैक्सिमम हो जाती है. मतलब हम जनरल डिस्टेंस x के बाद वेलोसिटी लिख लेंगे, और वेलोसिटी will come out as a function of x, right? By conserving energy we will write the velocity of each block as a function of x, right? So just a little correction here ki these arrows are shown in the reverse direction, so velocities will be away from each other. So let me just correct it. Right, so at initially the distance is 1 meters, फिर distance x हो जाता है, तो उस समय velocities दोनों की v and v हो जाती है. Because of symmetry the velocities will be the same, right? So we will conserve energy. Conserving energy, initial electrostatic potential energy in this situation when the distance is 1 is equal to finally the electrostatic potential energy plus the kinetic energy that the blocks have gained plus the energy that has gone into the work done against friction, that has been converted into heat. So this last term is the heat generated so far, right? तो एनर्जी कंजर्वेशन को ध्यान से सोचेंगे कि पहले सारी की सारी एनर्जी इलेक्ट्रोस्टैटिक एनर्जी में थी, फिर when the block started moving apart, there is still some electrostatic potential energy left, but some of it has gone into the kinetic energy of the blocks and some of it has converted into heat. So the final sum of all three must have come from the initial total electrostatic potential energy. Now this is just the function of velocity as this is a relation between velocity and x. We have not got explicitly velocity explicitly x के terms में नहीं है, but function है हमारे पास. So we can take the derivative of this function of this equation with respect to x. So x के terms में derivative लेंगे तो we'll get this equation. Now at the instant of maximum velocity, dv by dx must be 0. dv by dx must be 0, right? Or you can say v dv by dx must be 0, which is the acceleration, right? So जब dv by dx को 0 put करेंगे, so we'll get the value of x for which the velocity is maximum, right? And the rest is just calculation. तो calculation भी थोड़ा सा है इस question में. So JEE advanced में ऐसे questions भी आते हैं where there is some amount of calculation to be done, and calculation has to be done smartly, right? तो अब अगर x का ये फंक्शन लेता और फिर उसको फाइनली ओरिजिनल इक्वेशन में डालूंगा तो वेलोसिटी मिल जाएगी. बट अब ये फंक्शन जो है ये थोड़ा इतना अच्छा नहीं लग रहा देखने में, लाइक मतलब इट्स नॉट वेरी कंफर्टेबल टू हैंडल. इट्स नॉट दैट डिफिकल्ट, बट स्टिल इट्स बेटर टू डू द कैलकुलेशन हियर. तो x की वैल्यू मैंने यहाँ पे 3 निकाल ली, और फिर इस x की वैल्यू को वापस फर्स्ट इक्वेशन में डाल दिया, तो आई गेट द वेलोसिटी. अगेन सम कैलकुलेशन इज इन्वॉल्वड. So this is the answer, that the maximum velocity that the blocks acquire is 2 meters per second.